So first, we have the cosine of 2x. Okay, but the last result, we know this is equal to cosine square x minus sine square x. And we know sine square x equal to 1 minus the cosine square x, right? So now, from this identity in this first case, we can get another identity for the double angle of cosine. So we have the cosine of 2x equal to cosine square x. And then we replace sine square x by 1 minus the cosine square x. So we get the 1 minus cosine square x here. Now you multiply each part, okay, each term inside the parenthesis by -1. Then you get cosine square x minus 1, and then plus cosine square x, and then finally get the 2 times cosine square x minus 1. So this is the second form for the double angle identity for cosine. Okay, and you can also replace cosine square x by 1 minus the sine square x. So now let's get the third form of identity for the double angle for the cosine. So this guy is equal to, now let's replace the cosine square x by 1 minus the sine square x. Okay, so here we have the cosine square x equal to 1 minus the sine square x, and which is obtained from the fundamental identity, right? So now this guy is equal to 1 minus sine square x, and then minus the sine square x again. So you got 1 minus 2 times sine square x. Okay, so we have the 3 forms for the double angle identity for cosine. Now we can also get the double angle identity for tangent, and let's begin with the tangent of a sum. So we have the tangent of a sum identity. So tangent of x plus y is equal to tangent x plus tangent y divided by 1 minus what? Tangent x times tangent y, right? Okay, tangent x and times tangent y. So now we just replace, okay, we replace the y by x, and then we can have the tangent of 2x. So this is equal to, so tangent x plus tangent x, you have the 2 times tangent x, right? And the tangent x times tangent x, you have the tangent square x in this denominator. So now we find the double angle identity for tangent. Now let's look at some example to see how we apply this double angle identities. So let's go to the page 543, and let's look at the problem 8. So let's try to find sine of the 2 pi over 3. So actually, we can use the reference angle to find the value of this expression, right? But here, let's see how we use the double angle identity for sine to find this value. And let's remember sine of 2x is equal to 2 times sine x and times cosine x, right? This is the double angle identity for sine. So this guy is equal to, okay, let's first write this as the sine of the 2 times the pi over 3. So now, by this double angle identity for sine, we got 2 times sine of the pi over 3 and times cosine of pi over 3, right? Then, what is the sine of the pi over 3? Sine of the pi over 3 equal to what? Root of 3 over 2, right? Then what is the cosine of the pi over 3? 1/2, right? This guy is equal to 1/2. Okay? And then, finally, we got root of 3 over 3, right? Actually, this 2 and this 2 cancel, and then you get the root of 3 over 2. Okay. So, and this is same as sine of the pi over 3, right? So, same result, okay, as we get from the reference angle. Now, let's look at the one more example. Number 3, on the same page, we try to find the tangent of 60 degrees. Actually, we already know the value for the tangent of 60 degrees, right? So right now, let me just use this as example to see how we use the double angle identity for tangent. So, tangent of 2x is equal to 2 times tangent x over 1 minus tangent square x. Okay? So now let's use this double angle identity for tangent to find the tangent of 60 degrees. First, let's write this as the tangent of 2 times 30 degrees. Okay? And then, by this double angle identity for tangent, we got 2 times tangent of 30 degrees divided by 1 minus the tangent square of 30 degrees. And we know tangent 30 degrees equal to what? Root of 3 over 3, right? Tangent 30 degrees is equal to root of 3 over 3. So, denominator, this is 1 minus the square of root of 3 over 3. Now, let's simplify. Let me move here. So this is the 2 times root of 3 over 3. And this guy is the 3 over 3 square, right? After you square it. So that is a 1 over 3. Okay? So the square of the root of 3, 3, square of 3, 3 square. And then 3 divided by 3 square, you have the 1 over 3. So now, let's multiply the numerator and denominator by 3. And then you get 3 minus 1 as the denominator. And this guy is the 2 times root of 3, right? And then 2 over 2, okay, cancel. So you have the root of 3. So actually, this is just the value we expect, right? Tangent 60 degrees is really equal to root of 3. Any question? So by now you may think, okay, this double angle identity is not so useful, right? Because we just use them to find some values we are familiar with. But from the double angle identities, we can get the half angle identity, which is very essential and very useful to find the trigonometric values for some new angles. So now let's look at the half angle identity.